All right. Hey everyone, welcome to LlamaIndex Observability with OpenTelemetry. I'm Nir from Traceloop, and I have here Jerry from LlamaIndex. Great
Thanks,
to have
Nir.
you
It's
here.
great to be here. Thank you.
So every time I'm like talking in some like podcast or webinar, people ask me how to pronounce our open source. So I was wondering, like, how do you pronounce our open source for observability?
Yeah, I've been calling it OpenLLMetry, which I learned 5 minutes ago was not entirely the correct way, but yeah, but I've been calling it OpenLLMetry.
Yeah, so it's I think like so it's OpenLLMetry, and for some reason I think it's like it's a real tongue twister, and I think a lot of people have a really hard time to pronounce it correctly. But like the idea is that it's you have OpenTelemetry, and we've taken OpenTelemetry and we've extended it to support OpenAI and LlamaIndex, and this is like why we chose to call it OpenTelemetry. I think I've seen someone on Twitter asking, like, suggesting this as a name for something like that, something like what we were building. This is why we thought. I thought back then it would be a great name, but now people just keep asking me, like, how do I find it on Google? And so yeah, maybe it was a bad name to choose.
No, I mean, I'm sure you could play around with it.
Yeah. Maybe, I don't know if it's not too late to change the name. I know, like, you've changed, like, from you used to call it, we call the GPT index, and now you call it LlamaIndex.
To LlamaIndex. Yeah, I hope that we don't have to rebrand again. So I hope this name is stable.
Yeah. Cool. So it's great to have you here. I think for people who already joined us now, we have a comment section. I think you should have it on LinkedIn as well, but if you're connected through StreamYard, you should definitely be able to see it. And then if you have any questions you want to ask us in live, then just feel free to write them there, and we'll be happy to answer. Yeah, so let's start. I don't know. Do you also see, like, my video? Okay, freezes all the time. There's something with my video.
Oh, no,
cool. So yeah, Jerry, wanna maybe like to start by giving us like a quick overview of what is the LlamaIndex, for people who hear about it for the first time.
Yeah, so LlamaIndex is a data framework for developers to build LLM applications. We started off as a small open source project back in November 2022. Since then, we've evolved this into something that's very production ready and use that a lot of large companies to startups. That we have both a Python and TypeScript framework containing core abstractions, which contain a lot of the base stuff you need to build LLM apps, including RAG, agents, any sort of like document processing, summarization. And so we have a lot of core abstractions around these areas. And a lot of the abstractions are tailored towards helping you connect to your data. So data loading, processing, extraction into a vector store, for instance, and then afterwards doing retrieval and query orchestration. We also have a lot of advanced RAG techniques. That's one of the hallmarks of our Twitter account, is just posting about a lot of these new things that you can do over your data. And of course, we have a rich ecosystem of integrations with hundreds of like LLMs, vector stores, embeddings, data loaders to choose from.
Cool. I've been playing around a lot with LlamaIndex in the past couple of days, and I love it. Like, it was super easy for me. I was just saying to you before, like, it was super easy for me to like switch between different data sources and like trying out connecting to different data sources. And we're gonna see it in a while with demos that we've created. How did you like? Why did you decide to start working on LlamaIndex? Like, how did you come up with that, and what was the origin story of LlamaIndex?
Yeah, so I've mentioned this a few times, but the idea of like the origin story is actually quite simple. It wasn't like I had really planned this from the beginning. I knew I wanted to start a company, and I knew I wanted to do something in the AI space. But it was really just being at the right place at the right time. It was about 3 weeks before ChatGPT was released. I came out with I'd finally decided to start hacking on the LLM API that DaVinci, was made available. And so it came up with the initial open source project to really think about how to use this API on top of private sources of data. Because I think that was something that people were just starting to think about at the time is, this thing is pretty cool. How do we get it to reason over stuff that we store in our own repositories of knowledge? Obviously, since then, there's been huge advancements in the LLM space, with popularized by the rise of ChatGPT. Every proprietary to open source model provider is racing for longer context windows, better reasoning. But in the meantime, it became clear that there needed to be some sort of layer to basically allow developers to have a good time building these applications, similar to how web frameworks exist, right? To kind of install best practices and centralize certain abstractions so that you can just organize your application with the right architecture. It's something similar that's evolving for LLM maps, especially in the part that we care a lot about is the interface with data. I think, no matter what the current paradigm is or the future paradigm, there will always be a use case for using these cool models on top of data that you have. And then there will always be some sort of best practices around new use cases that emerge. And so our philosophy is just build the production grade tooling to enable developers to build for these use cases.
It's very cool. Actually, it's interesting, like you mentioned it, I think what the use cases that LlamaIndex started with is an ability for you to easily build a RAG pipeline, right?
Yeah. At the time, RAG didn't really exist, but RAG didn't really exist as a concept. I think it became popularized through, I guess, frameworks like us, plus individual hackers just starting to play around with things, and they realized that somehow combining embeddings with vector store with a language model was a pretty nice application to build. And so I think that was something that it basically emerged as a framework. And we can also talk about whether or not this will remain that way in the future, right? But regardless of whatever new use cases emerge, our goal is to basically provide the right tooling for developers.
And is it the most common use case you still see people use LlamaIndex with, RAG pipelines?
The most common use cases these days is definitely RAG pipelines. I think RAG is a pretty big use case within the enterprise right now, because at a very basic level, what people are interested in is I have all these sources of data, and I want to use LLMs over this data. And RAG at least lets me, ask questions and synthesize insights across this data. And so that's the main use case that a lot of companies are interested in. We're starting to see more and more companies expand that into something more agentic towards workflow automation. So not just a simple question answering search bar, but also this is able to perform actions for you and automate different processes for you. So that part is definitely something that we have some initial support for, but we're going to build out more tooling, right? Because that's really around tool use, API design, and agents. But a lot of companies are still in the stage of, they haven't quite cracked the problem of, I have hundreds of thousands, maybe documents. They're all different types. How can I get LLMs to understand it? And that part is still something that we want to solve.
And which you mentioned before that you support basically a lot of models, but do you have any model that you currently see as the winner when building RAG pipelines or other applications?
Yeah, I think the current one is probably still GPT-4, GPT-4 or GPT-4 Turbo. I am interested to see what the Gemini models will be like in terms of reasoning. Obviously, the context windows will be very long, and I think that will necessitate some changes, and happy to talk about that more in terms of how we think about use cases and what new use cases will emerge. But especially in terms of reasoning capabilities, GPT-4 is a winner right now.
Yeah, it's actually something that I've been reading a lot about this on Twitter, but that with the new large context windows by Gemini, and at least they claim that even with huge context window, the model is still able to use all the context efficiently. There've been some claims that maybe RAG is dead. I keep hearing RAG is dead every few months, but now RAG is dead for reals maybe. And people say that, okay, if you have a huge context window, you don't really need to retrieve data from vector data. Basically, just put all the data that you have in the context window, and that's it. And so the question is it true, or should we continue?
Yeah, I mean it's a great question. And maybe so I'm actually working on a blog post right now, and hopefully that'll be released in like 2-3 days, outlining some thoughts around this. And basically, the two responses to this is, one is our mission at LlamaIndex is, contrary to popular belief, is not just RAG. It's actually just being a framework to help users connect whatever LLMs are out there to data. And so RAG is an existing paradigm to help users connect LLMs to data. If under for whatever reason, RAG happens to go away or just evolve into something completely new as a paradigm, that's something we'll build towards, right? And that's the advantage of having an open source framework, which allows us to rapidly iterate and keep up with all the advancements. And it gives users a basket of options to choose from. Right now there's going to be long context models. There will also be like small context models. And so how do you think about the best practices to deal with each of these? So yeah, building the tooling education for whatever these use cases is a core part of our mission. And we think there's just value in being a framework to help users like connect different components together. Okay, now in terms of whether RAG is actually dead, I think there will certainly, Gemini Pro is pretty impressive, by the way. I have early access, and I throw in a bunch of documents, and it actually does quite well. You throw in like 5 like SEC documents, and it can recall information very well across those documents. Some initial observations is it takes like 60 seconds for it to generate a response if you like fill the entire 1 million context window. And I know they're working on some caching mechanisms so that given like some set of documents, you can cache the existing activations so that you don't have to reprocess every single document token basically at every step or every new query. That said, I think constant latency is still something to think about. That part we need to just like figure out what's going to happen there. But like the recall capabilities are very impressive. I think what's going to happen to RAG is a lot of the smaller decisions around like chunk level stuff will probably go away, which honestly is good for developers. I think most people agree that chunking is kind of like a hack anyways. But as long context models take off, a 1 to even 10 million context window is not enough for most enterprise knowledge corpuses. Most companies, once they see these capabilities, will try to expand to the gigabytes to terabytes of information that's available within their store. And first of all, like even the docs repo within LlamaIndex is like 16 million tokens, right? And so you still need to do some sort of chunking. But that chunking just might be more coarse. It'll be easier to not have to split hairs, like figuring out like chunk size or like super hacky like retrieval techniques, and you'll be able to get back like good results from that. And so that's basically what like we are going to probably work on enabling users to build new architectures with like the types of like document level retrieval that long context models enable, and that's our goal.
Got it. Yeah, I'm surprised to hear that like Gemini performs well, because I remember trying out, I think Anthropic, they announced like they released like the 100K token window like last year, and I remember trying it out and was surprised to learn like that it can't like it can't really process the entire token window, and sometimes it will just start to ignore parts. Like it has a tendency to like overemphasize the end of the window as opposed to things that you put more at the beginning of the token window.
Right. Yeah, I think that was a property of current models. I think it turns out a lot of the recent models are actually, or at least for Gemini, it's actually able to resolve some of those issues, like the lost in the middle problems that Claude and GPT-4 currently face. And I do think that's a temporary problem that'll probably go away. So it's nice to anticipate, at least like in the future, as all these models get better, what the evolved use cases will look like.
Yeah, definitely agree. But if you go back to RAG or like pipelines that fetch documents in general, what are the common pitfalls you see people that build these pipelines fall into?
I think most people build a lot of the pipelines without really fully maybe internalizing all the pieces that are like all the moving parts that are going on within the system. And so when they build something that has very like high levels of abstraction and then realize like things don't actually work super well under the hood, it's hard for users to go in and then try to, it's just very hard in general. It's like a hard problem for users to try to tune RAG to be more performant. The hope is that as best practices emerge this year, users will be able to use these higher levels of abstraction without really having to, deal with all the messy stuff underneath the hood. So chunking algorithm, data loader, retrieval strategy, all these things. There's probably we're working on like centralizing some of these best practices. Otherwise, it's overwhelming to too many people. And long context windows will probably also help with that as well. They'll just like alleviate certain issues so you don't have to worry about it as much. So yeah, I think some of the pitfalls is just like with the current setups, a lot of users aren't actually tuning the pipeline enough to have good performance, but the hope is that the need for tuning will also go down in the future.
So you think there will be a point where we won't need to it will just work? I will just choose the right sources and plug everything in, and that's it. I won't need to configure anything.
Honestly, yeah, probably. I mean, I think that's typically how technology advances in pretty much anything. It's just like even from just like very low levels of abstraction, if you look at like the network stack from like TCP/IP to the application layer, there'll be like standards that emerge, and then people will figure out like, generally speaking, you should do this to solve this problem, and then they'll create like good abstractions around that. And in this case, it is a little tricky because LLMs are black boxes, and it's hard to really deeply understand them to try to figure out what triggers the best performance. Nevertheless, there's so much interest and so much potential that inevitably you can't. Like as a AI engineer, there's no way you just want to spend your time tuning everything. And ideally, you want to build the cool stuff on top of just the existing infrastructure.
Yeah, I agree. How do you like if there are like issues? You have like something running in production. How do you even detect those issues? Like how do you know that something went wrong? I'm guessing one thing is just I can ask the user for like implicit or explicit feedback, but sometimes it's not really available, or I can't really trust it. So I'm wondering if there are any other ways to do that.
Yeah, I mean, I think one of these examples is using OpenLLMetry, and so using an observability tool. I think it turns out especially if you're composing just like very complex application logic using language models, it helps to have some sort of experiment tool as well as the debugger. And one really nice thing about being able to have some sort of experimental tool where you can like log, visualize your traces, and really understand, evaluate like each component of it, is it gives every AI engineer, software developer, data scientist visibility into what's going on, and then also gives you the tools to better inspect these things and diagnose, pinpoint where the issues lie, and figure out like solutions for those issues. And figuring out solutions is a lot easier once you actually diagnose where specifically the issues are arising. So I think having this basic tooling is quite helpful. And I think the other like general best practice approach is like I think a general thing that users can think about if they have enough time is to try to build stuff up at the component level, is to try starting small over like a small set of documents with and try to hold as many parameters fixed as possible and experiment with things until you're confident about the results. So what I mean is like you start off with like, maybe even a single PDF or like 5 PDFs. You use the state-of-the-art model, so at least like you don't have to worry about that. And then you try to, like tweak some parameters, and therefore if it fails, you just have a more limited set of things to work with, right? To try to figure out what's going wrong, and then you expand in terms of complexity from there. And that's a general practice to at least like make the problem more tractable, because if you just all of a sudden throw this like super advanced thing in as a RAG pipeline and just expect it to work out of the box, and it doesn't, then all of a sudden you're dealt with like this entire mess of parameters to deal with and try and you have to like you have to dig through that entire mess to figure out how to make the overall pipeline better.
Yes, you're saying start simple, start with the defaults, and then if you starting to tweak with parameters, just do it one at a time, and always work like on small batches and small data sources, so you can make sure that everything
everything still works. Yeah, and we've come up with a bunch of resources on this too. I think anyone who follows our Twitter knows we probably post a lot of this content, and so definitely there's and there's definitely overlap between this content as well. But we have probably 5 different resources showing here's a general cheat sheet of here's some issues that you can run into at every stage of the pipeline, and then here's potential solutions to address these issues. And so by starting smaller, you can maybe you'll have a fewer set of pain points to tackle. And then we have some best practices for solutions around some of these pain points, and then you can expand from there. Great. I enjoy I think I'm following you. I don't know if I'm following the LlamaIndex Twitter account, but I like reading your tweets and the posts that you publish. So I think might be soon time for start showing some demos around the things you can build with LlamaIndex. But before that, maybe you could think about something you're excited about in our domain for this upcoming year. I think things are moving. People always say it, but things are really moving fast, and every day you have crazy, exciting announcements. But is there anything specific you're excited about for the upcoming year? Yeah, I mean, a lot of things. I mean, long context models actually is one thing. I think it's just very interesting. I think another is just better RAG use cases. I think what we're building hopefully helps with that. We came out with Llama Parse this past week, which is a very, very good PDF parser, hoping to resolve some of these document issues when building RAG. And then also being able to ask more types of questions across scaling up to thousands, even millions of documents and getting back good results. I think our goal as a framework is to, the third category is multimodal stuff. I think we tried about this briefly, but being able to really leverage both images and text to reason over things, and then take actions, and then also do generations. And basically, if you can reason in a multimodal manner, that actually is, in my opinion, a step towards AGI, because that's basically what humans do, right? You perceive a bunch of different senses, you synthesize the information, and you perform actions. And I think that's very cool, maybe scary too, but for us, we're mostly excited about a more limited problem of knowledge extraction and synthesis. And so I think for us, that's very exciting on those ends. And then from our perspective as a framework, it's just to try to make everything production ready. We want to stay on top of whatever the new advancements are in the LM ecosystem, and then we want to provide just very robust core abstractions, and then also eventually services to enable developers to build for these use cases. Cool. Yeah, I'm also I think I find myself thinking a lot about multimodal, and I think we're gonna see I think this is where we're gonna see a lot of advancements in the upcoming year. I don't know why my video is always stuck today. Okay, maybe I will switch a camera. Yeah. Cool. So yeah, if anyone has any questions, feel free to comment. I'm looking at the comment section if there's anything specific we can raise. But in the meantime, we can go to see some demos of things we can build with LlamaIndex. Let's do it. All right. Let me present. All right, so here we have the first, we built 3 different examples showing different capabilities of things we can build with LlamaIndex. You're going to see how we can run them and how we can observe them using OpenLLMetry. Would you mind? So would you mind zooming in? Would you mind zooming in just one more time? Yeah. Okay, that's great. Thanks. Great. So the 3 examples are with Streamlit. So just so we have a nice UI to show. It does make the code a bit more complex, or might be a bit more difficult to read, but let's try to go over it nonetheless to see if we can explain it. So yeah, Jerry, you want to explain the first example? Yeah, actually, if you just scroll back up to the imports. So this, by the way, is an overall example that shows you how to wrap our famous 5 lines of code to build RAG into a Streamlit app. So it's probably the most straightforward starter example that you can use. And this will make use of our LlamaIndex v10 package, which contains both a core library, which is installed with every LlamaIndex install, as well as makes use of LLMs and embeddings. And actually, all of our hundreds of LLMs, embeddings, plus other integrations are versioned and packaged into separate packages. And so the nice thing about that is you actually preserve the namespace, like from LlamaIndex.llms.openai, import OpenAI, but all these are separate packages, which makes it easier for you to maintain and also add and remove integrations. So the first thing that we're going to do is just define what the embedding model is and the LLM. And so you can also pass these models directly into the downstream abstractions that we're going to use, like the vector index and other stuff. But this is a nice convenience abstraction because we realize that a lot of users just use one embedding model and one LLM throughout their entire application. And so you can just configure global settings class and just set the LLM and embedding model on there. So that's exactly what we're doing here. We have settings.llm equals OpenAI GPT 3.5 Turbo, and the embedding model is the text embedding 3 small model. And of course, there's Traceloop init. And of course, thanks to the work of the Traceloop folks, they did it in a way so that you just have to do it at the top level. And then no matter what LlamaIndex code you write, it basically just gets everything underneath the hood. There's callbacks and stuff. It just gets logged through to Traceloop.
Yes, so we'll see it in all the examples. Basically, people install a Traceloop SDK, you initialize it, you initialize it, and that's it. We monkey patch all the APIs of LlamaIndex, and we'll be able to see in a bit how the traces looks like. And yeah, because and we'll be able to see it in documentation later. I will show you as well. Because we're using OpenTelemetry, basically by switching, environment variables, you can connect it to whatever platform you're using. So I'm going to show you how this works with our platform. But you can easily switch to Datadog, New Relic, or any other of the 15 observability platforms that support OpenTelemetry currently.
Yeah, so it's a nice interface because you just fire and forget, and then it has nice integrations into downstream observability platforms. And yeah, so if we go down and walk through the core logic, some of this is just Streamlit, a boilerplate. A lot of this is actually, if there's a lot of Streamlit chat examples, many of which are using LlamaIndex. And so, you just set up, they have chat modules, you define a title, you have a chat interface. And then to build an index on initialization, what you can do is here we have a function called load data. And there's basically 2 core LlamaIndex modules here. One is the data loader, which is our simple directory reader. This is our most popular data loader, which will each point it to a directory, and then it ingests all data within a directory, or you point it to a list of files. And each file extension is parsed with a certain strategy. So PDFs will be parsed with a certain strategy, HTML files, PNGs, a lot of other stuff. So we load it into document objects, docs equals reader.load data. And then we put it into a vector store index from documents. For those of you who are familiar with RAG, vector store index from documents is the one line of code that just takes in any sort of input document objects and puts it into a vector index. And so it chunks it underneath the hood, splits it up, and then puts it into a in-memory vector store. Of course, you should probably use many of our vector store integrations if you're actually trying to bring this thing to production. But the vector store index on its own, the in-memory version, is a simple implementation. So it's a nice starter example. So that's the ingestion piece. You want to load data into this index so it persists. And I think st.cache resources is a Streamlit helper function that allows you to cache this so that if you reload the page, at least you basically don't have to reindex the data the entire time.
Yeah.
So you call index equals load data. And the next thing is, from now that you built the index, you want to derive some sort of query interface over this index. And RAG has a bunch of different components. Here we've abstracted it away into one line of code. And so I can try to explain a little bit about what's going on underneath the hood. But for those, like RAG is basically, once you have your vector index, you want to first do retrieval from the vector index. You fetch the top k most similar items from the vector index through embedding similarity. You take the retrieve context, put it into the LLM prompt to synthesize an answer. And that's basically how you want to set up a QA pipeline for RAG. The one extension here actually is we have, and so the default like standard RAG pipeline is a query engine. Here we're actually using what we call a chat engine. And a chat engine is basically a wrapper around an existing query engine that also maintains conversation history and state. Because we have this like conversational chatbot, what's happening is like every time you input something, you might not be able to treat it as an independent question. You might want to take the entire conversation history, condense it into a question to then feed to the RAG pipeline, and that's exactly what we do. And so when you see chat mode equals condensed question, what's really happening underneath the hood is at every given step when a user enters something, we'll take the entire conversation history, feed it to an LLM to try to infer what question to ask for this like RAG pipeline, right? Retrieval and synthesis. And then we'll execute the RAG pipeline and give you back the response. And then also append it to the chat history.
So this is a specific feature for the chat engine. So like the basic way of using these would be to call index.asQueryEngine. But here we have an example of like actually being able to chat with your documentation or whatever you've stored in the vector database. So then this is how you define how to like resend the previous chat history to the LLM.
Yeah, exactly. So at index.asQueryEngine is stateless, as chat engine is stateful because it maintains conversation history. And there's like 4 things that happen underneath the hood, and I hope I explained it. But you can basically do it in one line of code, and that's how it works right here. And the stuff below is basically also making sure we appended the conversation history and stuff to the internal chat engine, but we also want to make sure that that it's actually showing up on the Streamlit UI.
Yeah. Yeah, and then lastly here, this is how basically we invoke it. We just call chat engine.chat. We give it the user prompt, and that's it.
Yep.
All right, so we're gonna run it. And if we go here, we're gonna see the example, and yeah, so now it's actually running the indexing. It was pretty fast, and now I can ask any question that I want. There's like this the question I always have in mind, which is the question that you have like in the LlamaIndex docs, which is like, what did the author do growing up? When I want to ask something else, so maybe it will be, I don't know, when did the author, which is program, decided to start YC. I think it's there in the documentation. The blog piece. So we're indexing one of Program's blog posts, and then yeah, and we've seen actually it was able to answer. GPT was able to answer.
Yeah. I don't know if that was actually the correct answer, but
but it's interesting.
This is generally how it works. Yeah.
This is like an example of hallucination, but we can see. But I think it might be interesting to see what happened here behind the scenes.
Yeah, actually, so if you go here, because it could be due to retrieval, which I think you log, or it could be due to the OpenAI track call.
Yeah. So we can actually see here what happened behind the scene. We can see like the call to embeddings and everything, and definitely we can actually see what LlamaIndex provided to OpenAI with with all the context, which is as I see, like it's a lot of the blog post, and then this is the question: what did the author decide to start? When did the author decide to start YC? And then they also decided to start YC when we realized that they have stumbled upon a way to scale. Yeah.
No, yeah,
interesting
this is a
answer.
great example actually, because from a slightly failing case, you can basically show the use of why you want a tool like this, because you step through either the retrieval task, so you make sure the retrieve context is correct, or you step through the input prompt. And if the retrieve context is correct, but the LLM does not give you the right answer, then that's a fault of the LLM.
Yeah, and I think you can easily see that the excerpts from the blog post are not really relevant to the question. There's like times here, but yeah, it's like it's not really. I think like the problem here is that we don't have the answer. Like we don't have the information to answer the question. So then we just pulled out some random excerpts from the data set, and then this is the answer that we got.
Right.
Yeah, so basically what you see here is we ran the pipeline, we initialized Traceloop, and we connected it to our platform, and we were able to see everything that was happening with the time it took to do every step of the RAG pipeline with the prompts and completions. Everything is here. If you go to our documentation later, I'm gonna put it here. Then you can see we have like all the integrations, all the other destinations you can send the data to, and basically we get the same information. You're able to see the prompts, the completions, and all the pipeline in your favorite platform. Cool. I think it's time to maybe go to a more complex example.
Yeah, I'll sit.
So the second one is the query rewriting. So we have another pipeline here, but this time it's a bit more complex.
Yeah, and so a lot of the scaffolding looks very similar, including the load data piece. So we load in Paul Graham's essay, but I think the cool thing about here is this actually shows you how to compose a more interesting query pipeline beyond what we showed in the standard chat interface. And so this query pipeline contains both query rewriting as well as re-ranking. And so if you think about the standard RAG pipeline as you take in a query and then you do retrieval and then synthesis, this adds 2 more steps. So you take in a query, you first do query rewriting using a prompt and an LLM. And then from that rewritten query goes into a retriever, gives you back the relevant return context. And then you feed it to a re-ranking module, and then you feed it to synthesis. Part of the reason we want to do query rewriting is because a lot of times users are really bad at asking questions. And when you're bad at asking questions, you get bad retrievals. And that's like a case. That's the case with like search engines as well. And so what we show here is using an LLM, you can inject an LLM step in the beginning to try to rewrite the query into something that's more amenable for retrieval. And the other nice thing about this, which I really like about this notebook, is that we showed how to do things using our query pipeline syntax. And so LlamaIndex presents this syntax called query pipelines, which is basically a declarative way of composing a DAG around all of our modules. It allows you to declaratively compose this graph and a flow from input to output. And by composing it in this way, you can, 1, visualize it pretty easily, 2, take advantage of some syntactic sugar, because then you don't have to figure out how to manually convert outputs to inputs at every step of the way. And then 3, this will eventually can lead to nice benefits, like if we want to be able to serialize, deserialize this easily, and also optimize the execution under the hood in terms of like parallel execution. So the query pipeline, if you think about it as a DAG, contains nodes and edges, right? And so the core nodes that we have are prompts, LLMs, the retriever, the summarizer, which is the response synthesis module, and also re-ranker. So nodes you can think about as modules, and the input is the user input. And basically the user input flows through modules and gives you back an output. And so if you think about like a basic setup of how this works, you take in a user input, feed it to the query rewriting prompt, which will format that prompt template into a full prompt. And then you feed that prompt into an LLM, which will give you back an output. And then you take the output of that LLM and you feed it to a retriever, right? And so that first part is basically like a sequential chain. You take in a query, feed it to a prompt and LLM, and to a retriever. From there, on line 72 to 75, you feed in the output of the retriever to the re-ranker. And then the re-ranker also takes in the rewritten query from the LLM. And so that re-ranker node takes in 2 incoming edges, one from the retriever and the LLM. And then 74 and 75 is the outputs of the re-ranker go into the summarizer. And the summarizer also takes in the rewritten query from the LLM. And the goal of the summarizer is to, given the relevant context, synthesize an answer for you. So whereas the previous example just showed you how to basically do, query thing in like one line of code, this actually shows you roughly how to build it from scratch. And we give you a lot of flexibility in how you want to compose this query pipeline as well. You can define custom function components if you want, and we were able to stitch it together. And then if you scroll down, so this creates the query pipeline. I don't think it's shown in this specific example, but you can actually visualize a DAG in NetworkX as well. And so if you wanted to, you could just like throw this into NetworkX, look at what the graph looks like, and it looks very, it's a nice visual representation.
Yeah,
so
I was about to say that it's really hard to like figure out like what's happening here, and then you also have an option to like visualize it really easily. And I saw it when I ran it previously.
Yeah, and also the other benefit is besides visualization is of course similar to how like the benefit of being able to do something like this is you also get callbacks underneath the hood, which of course also hook into observability partners like OpenLLMetry. And so you can visualize your entire trace through this query pipeline and view it in a UI in case you want to debug something.
Yeah, and we're going to see it in a bit. Yeah, and then lastly, we have basically running it is pretty similar to other ways of like running query pipelines. You just once you initialize it, then you can just call run with the prompt. In this case, I don't know if everyone saw, but the first prompt is like forcing the user to just tell us a topic, and then we generate a question based on that topic, and then we feed it into the pipeline to generate the answer. So we just feed the topic here as a parameter, and that's it. So we're going to run it again. Rewriting. And let's go here and refresh. Right, let's just ask about Y Combinator. I think it should work. Should not hallucinate, I'm imagining. And so now, while it's working behind the scenes, yeah, okay. So we got an answer about how Paul Graham founded and developed Y Combinator. And again, if we go to see the trace, we want to see the graph, we'll be able to go here. And because we initialized OpenLLMetry behind the scenes, we'll be able to see the query pipelines with everything that's happening behind the scene. In this case, we had a call to Cohere for doing re-ranking, and we had the OpenAI call at the end. So we can actually see that we asked the OpenAI to generate a question on Y Combinator, and the question was, what role did Paul Graham play in the founding and development of Y Combinator, and how has his involvement shaped the trajectory of the company? It's a well thought question. So yeah, it makes sense like why the answer always talked about like founding and development, because this is something that was apparent here in the question that was generated by OpenAI. Pretty cool.
Yep.
It was really easy to set up. All right, let's go to the last, and like for me, this is the most exciting, one of the most exciting parts of like using LLMs, which is like autonomous agents. So let's go to the third example we built here with the LlamaIndex.
Yeah, and so agents are some core concept in LM development. LlamaIndex supports agents. Many people have different definitions of what an agent is. In this case, we'll show what an agent is that contains many more components than what we showed in the previous few examples. So an agent in this case is something that is able to do one, chain of thought reasoning over a given question. Two, so you break it down into a set of sub-questions. For each sequential reasoning step, you can figure out what tool to use, right? So you'll give it a set of tools, and it'll figure out how to use an existing tool. it will infer the input to a tool and get back an output. And then it will continue iterating in a loop until it's done. So a few core components of an agent: one, a reasoning loop, two, tool use. And we basically show that an agent can be composed on top of an existing RAG pipeline. One thing that we're very interested in for agents is how do you take advantage of this like reasoning tool use paradigm and use it on top of something that you already built, which is like, say, a RAG pipeline over an existing data source. So actually, in this example, it's quite interesting because we will show you how to create a React agent. This agent will have access to two tools. One is a text-to-SQL tool, and the other is a RAG pipeline tool. And by
So maybe we
calling
should
each
start
tool,
with the agent itself.
Yeah. So here, we'll scroll down and take a look at how these tools are defined. A tool is basically, think about it as an API interface for an agent to call. An agent will infer the input parameters for this API interface, execute the API request, and get back an output. Here we have two tools, a SQL tool as well as a vector tool. They're both wrappers around Query Engine and LlamaIndex. And a Query Engine, of course, is just you send in an input and get back a response. So the SQL tool will take in a text-to-SQL query engine, which we didn't explicitly show in the previous examples, but basically, we show in this example where we are able to define a text-to-SQL query engine over a very toy SQL database. Underneath the hood, it'll convert the text into SQL statement, execute the SQL statement, get back the retrieve rows, and then synthesize a response. So actually kind of similar to a RAG pipeline, but aimed at structured data. And then the vector tool is our vector query engine, which is similar to the previous examples. You index some unstructured data and get back a query engine that does naive RAG over this. And so that can be wrapped as part of a query engine tool. So now that you have these two tools, we have descriptions for each tool. These descriptions are useful because when you eventually feed these tools to an agent, the agent needs to understand what each tool does, and so that it can best pick the right tool for the job. Here, because one tool is structured data, the other is unstructured data. The structured tool description is, this tool is useful for translating natural language into a SQL query over a table. So you're telling the agent what this tool is good for. And then the vector tool, of course, is a tool that's useful for being able to understand semantic questions about different cities. The data source for the vector tool is just Wikipedia pages about like a bunch of different cities. So it's a toy example. I think we put in like Boston, Chicago, like Toronto or something like that. And then the SQL tool is just more tabular stats for each city, like city name, a country, and like population. So again, very, very toy example. But this shows you an example of something which contains both structured and unstructured data. And so you pass this both into a React agent. And so you have like React agent.from tools. And that's basically something that will build an agent from an existing set of tools and execute over it using the React paradigm, which is there's a bunch of new agent things that have come out since then, but this is one of the classics where this came out in 2022, and it's basically combining chain of thought with tool use. So given a question, you'll break it down into a set of sequential steps, and each step you'll figure out what tool to use, and you'll continue executing until you're done.
So, and then maybe you should go and show how these tools are built as well, because I think it's also pretty cool.
Yeah.
We have here the one that's like just indexing some data from Wikipedia, and so it's the same, right? The vector store, and as we've seen before, I think there's nothing new here.
Yeah, that's just using a vector store, and then this is the SQL tool. So that's this is the part where you're able to construct a query engine over like a SQL database. Here we just use like a SQLite database, and insert some sample rows. So you can see there's only 3 points in this database. And text to SQL can be pretty complicated. There's plenty of things you can do to try to optimize this, and this is just the basics. But we inject like 3 sample rows with city name, population, and country into the SQLite database. And then we have this abstraction called, it's a bit of a mouthful, we'll try to make it simpler, but NL SQL Table Query Engine, which basically just stands for natural language SQL query, like a natural language SQL query interface, which is just text to SQL. And so this text to SQL query engine takes in that SQL database that you put stuff into, defines, lets you specify the tables you want to operate over. And then again, you put in a natural language query and get back the response.
Yes, this is basically just an SQL Alchemy database that we're using here. We're wrapping it with SQL database, and the natural language one is basically allowing the agent to ask questions like in natural language, then it gets translated into an SQL query that is being run with SQL Alchemy on the actual database.
Mm-hmm. Exactly.
Yeah, and yeah, so I think although like this is a toy example, like switching, the SQLite database that I built here with some complex database is just a matter of like changing 2 lines, which is really cool. And lastly, same as before, for running it, we just there's a chat API for sending the prompt from the user, and then we get the answer. So we're gonna run it here. Oh, before I'm gonna run it, I'm gonna show you 2 more things that I've added here in this example actually. So for this example, because we are doing some complex like indexing and building before we are running the agents, I've added these 2 annotations that we have as part of the OpenLLMetry SDK. I have here an annotation called workflow. I put it above this method and above this method as well. And what basically this does is it tells the SDK that this is some workflow that needs to be traced, and then everything that's happening within this workflow gets traced, and we'll be able to see it in the UI in a second. And then the second, and the cool thing is that, like, let's say we have like we are doing a lot of things here for building the SQL database, or here for like fetching data from Wikipedia and storing it in the vector database. So it's really easy to see everything sits in one workflow, and this is being done just by adding this annotation to the top of the method. Yeah, so let's run this last example. Okay. And go here. All right. So we have an SQL database with data about 3 cities, and then we have the Wikipedia pages for these 3 cities. And so what we want to do is we want to have triggered something that will make the agent go to the SQL database to do something, and then go to the Wikipedia to the vector database to fetch some data from there. So we can ask, for example, like tell me about the arts and culture. I think it's also from the LlamaIndex examples. Tell me about the art culture of the city with the highest population. Basically, because we have this data in the SQL database, we expect the agent to go and fetch the data from there, figure out which city has the largest population, and then go fetch the relevant data about the arts and culture of the city from the Wikipedia page. So while it's thinking this will take a bit more time, we can go here and see what I've talked about before, which is the indexing. So I've created these 2 workflows of like load Wikidata workflow and load SQL database workflow, and we can actually see everything that was happening to fetch data from Wikipedia. And because again we're using OpenTelemetry, we get the benefit that we can actually see the request that were being made to Wikipedia to fetch the pages, the calls to embedding to embed those documents into the in-memory vector database that we've built. So it's pretty cool. And similarly, I think we can also see it here for the SQL database. We can actually see the calls that were made to build the database that we then used. Oh, and we got a city. This is Tokyo. This is the right answer, I think. And then some information about Tokyo. It is. What were the last 3 cities of Tokyo, Berlin, and London, I think?
Yeah, I mean, also Tokyo is just the biggest city in the world, so there's just no way there's any other city that is the right answer.
Yeah. So yeah, if we go here, we can see this would be a much more complex trace because we have like calls to database, and we can also see them here because we are tracing them with OpenTelemetry, and we have all the calls, the tools that were made. You see here the tool that actually made some calls to the vector database, to the SQL database. Yeah, we can actually even like track what was happening here. We started with a call to OpenAI that tried to figure out which tool to use. Then it realized that it should use the query engine, the tool that queries the SQL database, made a bunch of queries, then used those queries like, I think this was like translating the question that was done in a natural language into an SQL query. And then we actually made that SQL, the query to get the population, the population of all the cities that we have. Then we translated it back, like the answer we translated back to something that we can fetch back to, feedback to the agent. And then we call back the agent to figure out what to do, which calls the vector database to get the data from the Wikipedia. And then finally, we were able to get the final answer here. This is fairly complex, and I'm always surprised that it just works just like that.
Yeah, this is impressive. I haven't actually seen the agentic interface for Traceloop yet, and so I'm glad. Sometimes there are some like kinks to go through the underlying query calls, but I'm glad this works.
Yeah, so I think like when I was I think the problem with agents is that there's a lot of things that can go wrong, and then like you can easily get like to ask a question where it just go into like this endless loop where it can't figure out which tool to use, or it tries to use an existing tool, and so I think like being able to trace what's happening within the system and being able to actually see all the calls to OpenAI, all the translations that we have implicit in the framework, I think it's really useful for debugging and fixing these types of errors. So yeah, it's really nice when it's working, and when it's not working, it's really nice to be able to debug it. Yeah, that's it. All of these examples are in a repo I've built, and it's available, so you can go to GitHub, Traceloop/LlamaIndex-demo, and you'll have all the examples here, there, and how to run them. And then again, if you want, after you install the SDK to debug LlamaIndex, you can easily connect it to whatever observability platform you want. And if you have any more questions or anything, so this is documentation, traceloop.com/docs for the OpenLLMetry. And if you have any questions you want to ask specifically around OpenLLMetry, we also have a Slack channel. I think LlamaIndex has a Discord. You can also join if you want, if you have any questions around LlamaIndex. And I think that's it. I think we are exactly on time.
Perfect. Yeah, thanks so much for setting this up, and excited to walk through this. Hopefully this is helpful for the audience. We really went through both like simple to advanced RAG workflows, and yeah, I mean, again, the fact that this works out of the box with OpenLLMetry is honestly quite underrated, and really like this should just be a key part of every developer's workflow. So highly encourage you to check it out.
Yeah, it was great chatting with you this hour, Jerry. Have a great rest of your day.
Great. Yeah, thanks, Nir, for having me. All right, cheers. Take care.